Welcome students for the chemistry lecture B.Sc. first semester second paper number 3 physical chemistry. All of you know you have studied in the unit first regarding the thermodynamics, and thermodynamics, it is the quantitative study of heat and other forms of energies. And this word thermodynamics, it is derived from the Greek word, and the meaning of thermo means heat and dynamics means power. That is, thermodynamics studies the quantitative relationship between heat and other forms of energies. That means other forms of powers. Then the thermodynamics, it is studied with the help of laws. That means the first law, second law, third law and zeroth law of thermodynamics. Then you have learned the basic concepts of thermodynamics. Here energy, it is the capacity of doing work, or energy is defined as capacity to do work. Then the work means it is the motion against a opposing force, and it is expressed mathematically as W, it is equal to force F into motion, that means small displacement. Then you have learned the next thermodynamic term, that is the enthalpy. And enthalpy, it is the heat content of the system. It is expressed in joules and denoted by letter H, either capital H or small h, and it is the sum of internal energy plus pressure volume type of work, that is the product of P into phi. Then you have learned what is the system, and system, it is the any region or matter on which we concentrate our attention for study. Then surrounding, the remaining part of the system, it is termed as surrounding, and the system and surrounding, they constitute a universe. That means the in thermodynamics universe, it is the system plus surrounding. Then any system, it has a boundary. That boundary, it may be imaginary or real. Then you have learned the types of systems. Here, open system, in which exchange of energy and matter, it takes place with surrounding. Then second type, it is the closed system. In closed system, there is exchange of energy but not the matter, and in case of isolated system, there is no exchange of matter as well as no exchange of energy with the surrounding. These are the types of systems. Then the thermodynamic processes. A process means it is a operation, and by performing that operation, a state of system, it changes, and depending on that we have cyclic process. That means after performing the different steps or different cycles, we retain the initial state as it is, and such processes, it is equal to cyclic process. And remember that in case of cyclic process, the change in internal energy, that means delta E, it is equal to 0. Then reversible process. Here reversible process, it is a process in which there is a equilibrium in between system and surrounding, and the temperature and pressure of the system, it remains always constant. And a reversible process, it takes place in a both the direction. That means in a forward direction and as well as in a backward direction. And this reversible process, it is changed by changing infinitesimally small amount either pressure of the system or either temperature of the system. Then the irreversible process. Here irreversible process is a process which takes place in a one direction, unidirectional process, and the change produced is a rapid change, and it is not in a pressure and temperature equilibrium with its surroundings. The process is called as irreversible. I repeat, irreversible processes are the processes if the change in if the change is produced rapidly and the system is not in pressure and temperature equilibrium with its surrounding, then the process is called as irreversible. And remember that irreversible processes are unidirectional, natural, and spontaneous processes. For example, flow of heat from hot body to the cold body. Then the flow of a river. Then the blossoming of the flowers. Then growth of plants, animals. All these processes are spontaneous and irreversible. Then here a state of system. That means if we fix either temperature, either pressure, either volume, depending on that we can have a different states of systems or processes. In case of isobaric process, in which we kept a pressure constant and we carried out the volume change. Such processes are called isobaric processes. Then the properties of system. Here the properties of system is a measurable characteristic of a system that is in equilibrium, and there are two properties of system: intensive properties and extensive properties. Here intensive properties are dependent on the amount of mass present in the system. Remember, intensive properties, they are independent of the amount of mass present in the system. And for example, temperature, pressure, density, etc. are the intensive properties of the system. Then extensive properties. Here extensive properties, they varies directly with the mass. That means extensive properties, they depends on the quantity of matter present in the system. And for example, mass, volume, energy, enthalpy, entropy, all these are extensive properties of the system. That means they depends on the matter, quantity of matter present in the system. You know, there are two properties of system: intensive properties and extensive properties. Then here the thermodynamic variables. Here temperature, pressure, volume, concentration, they are the variables of the system. And remember, by fixing temperature, pressure, volume, composition, we may state a system completely, or we define a system completely. And any change in the either temperature, either pressure, it may changes the state of the system. So A state of system is defined by specified thermodynamic properties. Remember that a state of the system is defined by specifying the thermodynamic properties. Then the thermodynamic functions, and there are thermodynamic functions are here internal energy, entropy, enthalpy, Gibbs free energy, Helmholtz free energy. And thermodynamic functions means when different thermodynamic terms or thermodynamic uh, functions, they are related with each other. For example, internal energy, it is the it is given by dq minus dw. That means here there is a relation between heat and work done, and the difference of heat and work done, it is given by the internal energy. Then entropy, it is given by the ratio of heat absorbed to the temperature at which heat is absorbed. Here this small q, it is the amount of heat absorbed at temperature this T. Therefore the entropy, it is defined as, or it is expressed as, yes, it is equal to dq by T. Then the next thermodynamic function, it is the enthalpy. Here enthalpy, it is equal to E plus Pv. Then the next thermodynamic function, it is the Gibbs free energy, and it is given by G, it is equal to H minus Ts, where G, it is the Gibbs free energy, H, it is the enthalpy, T, it is the temperature, and S, it is the entropy. Here the product of temperature and entropy. Then the next thermodynamic function is the Helmholtz free energy. It is denoted by letter capital A, and it is equal to E minus Ts, where E, it is the internal energy. Then state functions. Here internal energy, enthalpy, Gibbs free energy, Helmholtz free energy, entropy. These are the state functions. And state functions means they depends only on the initial state and final state, and not the path followed for the completion of that state or completion of that process. The delta E, that means change in internal energy. It depends only on the internal energy of final state minus internal energy of initial state. Similarly, the change in enthalpy delta H, it is equal to H2 minus H1, where H2, it is the enthalpy of final state and H1 enthalpy of initial state. Similarly, delta G, it is the free energy of final state minus free energy of initial state, and so on. Here entropy, it is also a state function. It depends only on initial state of entropy and final state of entropy, and the change in entropy, it is given by delta S, and it is the S2 minus S1, means the entropy of final state minus the entropy of initial state. These are the state functions. Remember, state functions, they depends only on initial state and final state, and not the path followed for the completion of that process. Then A system undergoes thermodynamic processes when there is some energetic change within the system. Here, thermodynamic process means when there is some energetic change within the system that is associated with changes in pressure, volume and internal energy. There are four types of thermodynamic processes and that have their unique properties, and that processes are adiabatic process. Here, a process where no heat transfer takes place or from the system. Here, no heat transfers into the system or out of the system occurs. Such processes are called as adiabatic process. Then isochoric process. Here, a process where no change in volume occurs. The system does no work. Such process is called as isochoric process. Then isobaric process, a process in which no change in pressure occurs. That means the process which is carried out at constant pressure. And the next, it is the isothermal process, a process in which no change in temperature occurs. That means here for isothermal processes, delta T means change in temperature, final temperature and initial pressure. In initial temperature, these two are same. Therefore, for isothermal process, delta T equal to 0. Isobaric process, delta P value equal to 0. For isochoric process, delta Phi equal to 0. And for adiabatic process, here Q, heat absorbed or heat evolved, it is equal to 0. No heat change takes place. These are the thermodynamic processes. Then a state and equilibrium. At a given state, all properties of system have fixed values. If the value of even one property changes, the state of the system changed and thus it becomes a different state. In a system that is in equilibrium, no change in the value of properties occur when it is isolated from its surroundings. Okay, so a state of system, it is fixed by fixing a variables of a system. Then here a process and property, which property it is held constant. Here for isobaric process, pressure is constant. For isothermal process, temperature is constant. For isochoric process, volume is constant. And for isotropic process, entropy is kept constant. Then in short, the thermodynamics, it deals with the quantitative study of heat and different other forms of energies. Here, mechanical energy, thermal energy, electric energy, chemical energy. Remember well, all these energies are distinct and different, and all these energies are interconvertible. Here mechanical energy, it will get converted into thermal energy, it will get converted into electric energy, then electric energy, it may get converted into chemical energy. And this interconvergence of heat and other forms of energies, it is quantitatively studied in the thermodynamics. Then let us turn towards the next point. Here the first law of thermodynamics, and all of you know the first law of thermodynamics, it is the law of conservation of energy, and it is stated as the energy neither created nor destroyed, but one form of energy it will get convert into another form of energy. So the energy of the universe is conserved. This is the first law of thermodynamics. Here the energy of the universe. Universe means the system and surrounding. That is the energy of the universe is constant or energy is conserved. Then the first law of thermodynamics tells us that the internal energy of a system can be increased by adding energy to the system or doing work on the system. And there are many processes through which this could be accomplished as long as energy is conserved. Here there is a interconversion of heat into work and work into heat. Here this is the but total energy it remains always constant. This is the law of thermodynamics, first law of thermodynamics. And the internal energy E internal, that it is of the system, tends to increase if energy is added as a heat Q, and tends to decrease if energy is lost as a work done W. And mathematically, the first law of thermodynamics, it is given by dE, it is equal to dQ minus dW, where this small d, it is the infinitesimally change in energy. This d, it is a infinitesimal, very small amount of heat Q is absorbed, and here this small d, it is also a very small amount of work is done. And if the finite change is there, we can denote it is by delta sign. So in this equation, Q is the heat absorbed and W is the work done by the system. The quantity Q minus W is the same for all processes, and it depends only on initial and final states of the system and does not depend at all on how the system gets from one to the other state. This is simply conservation of energy. That means the difference Q minus W, it is equal to internal energy of the system. Then here again the first law of thermodynamics states that energy can neither be created nor be destroyed, but it can be converted from one form to another. It is the law of conservation of energy, and according to this law every conservation of energy is possible. Like we can convert work into heat or heat into work, but practically whether the work is converted 100% into heat and whether the heat is converted 100% into work by natural way, these are the studies occurs in the first law of thermodynamics. Then again the first law here we can show diagrammatically. Here heat transfer takes place from hot body to the cold body. That means the flow of heat, it takes place from higher temperature to the lower temperature. This is the first law of thermodynamics. Then for tomorrow's lecture, we will see the second law of thermodynamics, and I request you to ask your doubts or problems in the understanding, and if you are unable to observe the telegram's link, you may go to the uh, video and put there my name, and you can see there the videos of your syllabus. You can study the your topic well. Thank you.